All right, so today, as I said, we're starting to put together the different building blocks that we've learned previously. Array operations, input, output, user-defined functions, branching and looping. So this is one of my favorite textbook titles by a famous computer scientist, Nicholas Wirth, who created a programming language called Pascal that was leading edge in its day, but it's kind of obsolete now. Algorithms plus data structures equals programs. That pretty much sums it up. When you're writing a complex program, you have to think about how am I going to store the data? And then what is the sequence of steps that I'm going to go through? That's what we mean by the algorithm. All right. So an algorithm, again, is just a sequence of steps. We talked about this in 1181. Sequence of steps to solve a problem. A computer program is an implementation of an algorithm. It's not an algorithm in itself. But a good algorithm should be correct, give you the right answer or a valid answer. It should also be efficient. It should be able to complete the problem even for large inputs in a reasonable amount of time with reasonable computing resources. So you might have heard about the prime number factorization problem, which is key to cryptography. And one of the reasons people are working on quantum computers is to try to break that problem. Well, it's not that there's no algorithm to do prime factorization. There is, it's just that it's not efficient enough to be useful. Because if you give it a large number, it just takes forever to run. Okay. So to be useful, an algorithm has to be efficient enough that it can run on large inputs. And it should be robust. That is, it should work reliably, even on special cases. And this is one of the major sources of software bugs, where somebody didn't anticipate some special case. They made an assumption about what the inputs would be, and then a special case comes along that violates that assumption, and the program doesn't work. All right, so here's what we're going to do for the first problem. We're going to think about how to load a truck. We have a list of the weights of some cargo items, which are just going to be numbers in an array, the weight of each item in pounds. And we have a truck with a maximum capacity, and we just want to load enough items load as many items as we can onto the truck. So we'll have a list of items that has some order to it, but they're not sorted. At least for starters, we're not going to assume that they're sorted. All right? So what are we going to do? Well, there are different algorithms you could use. We're going to start with the simplest possible thing. You just go down the list in order. And you look at each item and you ask, is there still room on the truck to load this item? If it is, you load it. You go to the next one. Is there enough remaining room on the truck to load this one? If so, you load it. If not, you skip it. You go to the next one. Okay. And then you get to the end of the list and you're done. All right, so here's how this will work. Let's say here's our list of weights, and our truck has a capacity of 1,000 pounds. We start at the beginning of the list, and we ask, is there still enough room to put 400 pounds on the truck? Well, sure. So we load it. Now our remaining capacity is only 600 pounds. We go to the next item. Can we load 250 pounds? Sure, it's less than 600, no problem. So we load that. We go to the next one. Do we have enough remaining capacity to load 700 pounds? No, we don't. We only have 350 pounds left. So we have to skip this one. All right, do we have enough capacity left to load 60 pounds? Yes, so we load that one. Now we've got 290 pounds left. The next weight is 300 pounds. We can't fit that one on, so we skip it. All right, and then you end up with this. You load the 120 and then the 10. And we've loaded 840 pounds of total cargo, which means we wasted 160 pounds of our capacity. Right? The truck isn't really full, but we've got to send it off anyway because none of our remaining items will fit. Now, it should be obvious, this is not the optimal solution. We could have come up with a much better solution. Just load these two items and you're at the full 1,000 pound capacity. You aren't wasting any of the capacity of your truck. All right, so this simple algorithm isn't going to give us the best solution, but it'll give us some valid solution that's good enough for starters. All right, so what does the algorithm look like? Something like this. All right, so we start out, our remaining capacity is just whatever the capacity of the truck is. And we start at the beginning of the list. And we look at the next weight, in other words, the next weight in the list. And we ask, is that less than or equal to our remaining capacity? If it is, we load it, which means we need to subtract that weight from the remaining capacity. Right? We just reduced our remaining capacity by loading this weight. And then we go to the next item in the list. If we get to the end of the list, we quit. If we're not at the end of the list yet, we go back. All right, so I mentioned last time, when you see backwards branching in a flow chart, that means it's a loop. Right, so we've got a loop here. And within that loop, we're asking this question and taking some action. All right, so you can kind of picture, we're going to have probably a for loop. It could be a for or a while. In this case, we can just use a for loop. It's simple enough. And within that loop, we're probably going to have an if statement. Right, so that's going to be an if statement. And this is going to be a loop. Now, a thing to keep in mind, if you do it with a for loop, some of these things happen automatically. You don't actually have to put a line of code to do it. All right? If you use a for loop, these three things all happen automatically in just one line of code, right? Which is for list position equals 1 to num items. And what's num items? It's just the length. You can get num items from just using the length function. So in the exercise, we're going to give you an array called weights. You just take the length of weights and that's the number of items, right? So we're just saying loop over all the elements in the list. And within that, do an if statement to see if this next weight will fit on. If it does, load it. Otherwise, just skip it. All right, so that's the program. All right, so let's go to the grader. All right, so you can see the grader is generating a list of weights. So if I do disk weights, you can see what that looks like. Okay, it's just a list of numbers, the weights of the items in pounds, and it's random. It's going to change every time. Okay, so there's just some function behind the scenes that's doing this for you. But it's set up so that the sum of the weights will always be greater than the capacity. That way, there's no trivial solution where you just load everything. All right, and then you just have to implement this algorithm that we just talked about. And again, the simplest way to do it, a for loop with an if statement inside. All right, and just again, I have to reiterate this. Remember, if you're using a for loop, you don't literally need this line of code because it's being done by the for loop. And the same with this one. You don't actually have to have a line of code to do that. It's happening automatically with the for loop.